So the second law of thermodynamics basically says, well, one of the many things it says, is that no heat engine can absorb heat and convert 100% of it to work. There always has to be some leftover heat. What that basically means is, well, conservation of energy says that you can't win. You can never get more energy out than you put in. The second law of thermodynamics says you can't even break even. You're never going to get out of a machine everything that you put into it in terms of useful work or useful energy. Some of that energy is always going to be degraded and spread out into less useful energy, like almost always thermal energy. Now, William Thomson, aka Lord Kelvin, studying the Carnot engine led him not only to the second law of thermodynamics, but to the calculation of absolute temperature. Lots of people had thought that absolute temperature probably existed as an idea, but their calculations ranged all over the place. They weren't so much calculations as guesses, and they ranged from like minus 1,000,000 degrees Celsius to minus 5,000 degrees Celsius to whatever. And Thomson very precisely calculated that as minus 273 degrees Celsius is 0 Kelvin using the study of the Carnot engine. And that led him also to this idea of energy degradation, that energy can be spread out more into finer and less useful forms. So the study of the Carnot cycle actually allowed Rudolf Diesel to develop a much more efficient diesel engine as well. And that was about 85 years after Carnot. Carnot was 1824. And the diesel engine, we still use them today. They're significantly more efficient. So using the theory of the Carnot engine, people were able to make really important practical gains using the idea of the second law of thermodynamics as well. Entropy is often thought of as disorder. If I have a bag of marbles and half of them are red and half of them are green, and I start pulling marbles out one at a time, you figure after I've pulled out 1,000, the odds are really good that I'm going to have pulled out about 500 red and 500 green. If I pulled out 1,000 green, the odds of that are vanishingly small, isn't it? And the reason actually has to do with entropy. This idea of entropy is that there is a measure of how ordered a system is, and without the input of work, so that the system isn't closed, without the input of work, that number can never go up on its own. Entropy will always increase, order will always decrease. And you're not going to have to do any entropy-related math in this class, and to be honest, I'm just going to be quiet about it and show you these videos here. Henry over at Minute Physics, along with Sean Carroll, put together a series of videos on entropy, which are kind of mind-blowing. One of the implications is that physics doesn't have an arrow of time, meaning anything that happens forward in time, the laws of physics say the same thing could happen backward, except when dealing with the concept of entropy. The concept of entropy always increasing might be what gives time its meaning. Time might be a statistical phenomenon rather than an absolute phenomenon. And those are some pretty mind-blowing ideas, so make sure to check out the Minute Physics videos up here on the tag and in the comments down below.